All right, so we're back. We're talking about nuclear energy, and it fits into this idea of renewable or alternative energy for several reasons, several of which we've already talked about. The biggest one being that it doesn't release carbon emissions, and yet we have to acknowledge that while it doesn't release carbon, there are other emissions that we have to think about. But compared to fossil fuel, the emissions rate is so much lower that nuclear energy really is seen as a much uh, cleaner form of alternative energy. One of the biggest challenges, though, is that the uranium that is used to produce the fission reaction that gives off the immense amount of energy that can be harnessed to make electricity is still radioactive and still decaying even after the fission event has taken place. And at least the United States does not have a simple method by which to dispose of this radioactive waste. And while other countries, such as France, have established technological advances that allow for this spent uranium to be recycled. That's not something that's being done widely around the world and including in the United States. So we could summarize the environmental costs in a couple of different ways. One is, what are we going to do with this radioactive waste? Where is it going to be stored, and how are we going to recycle it? Second is, we talked about water moving through the power plant to help moderate the process of fission. And as the water is released back into the environment, it can be several degrees warmer than when it went in, and that is an issue. The last one, and the one that got the most attention when nuclear energy became pretty dominant as a alternative way of generating electricity, is the risk of nuclear proliferation. That is, uranium that is spent still having radioactive components means that it can be used for nuclear warheads. And that is a concern that our country and other countries have about if that were to fall into the wrong hands. And of course, the risk of nuclear accidents looms in our minds, just like when we think about parallels to, say, a plane crash. It's not something that happens often, but the risk to human life is so great that that becomes a huge, huge consideration. So if we look to an example of something that took place here in the United States, it wasn't exactly a nuclear meltdown, but 3 Mile Island had an issue where there was an accident due to human error and mechanical failure that led to water not being able to stay inside the reaction vessel. And we know that that helps to manage the fission reaction. So this led to the start of a meltdown with the rods beginning to melt, and that did give off uh, quite a bit of radiation, although it was able to be stopped relatively quickly. So it prevented such a catastrophic event such as Chernobyl and then later Fukushima. So 3 Mile Island was considered a near miss, whereas Chernobyl's explosion was quite detrimental to the region in Ukraine. And while the effects were felt immediately, we can still see those effects taking place even today, even in nature, even if people in that area have left. Fukushima was sort of a cataclysmic event where it was a earthquake that led to a massive tsunami, and that really shut down the power and the backup generators, and then it inhibited the water that's cooling those fuel rods from still being able to keep them cool, and that's what led to that meltdown. And interestingly, because it was so close to the coast, the radioactive material actually made it into the water, and they could test fish that were hundreds and thousands of miles away, still picking up that radioactive material. So the challenge of what to do with this spent fossil fuels of uranium is still a major issue today. And right now, the spent uranium is kept right on the property of the plant. There is a thought that maybe this should not be the case, that all of the spent uranium should move to one centralized area so that it can be guarded and make us less at risk. In any one of these places, just put it in one place. One of the challenges there is that nobody really wants to pick a place to put it. Yucca Mountain in Nevada has been talked about for about a decade, where they would basically drill into the mountainside and put all of the uranium there, and in hopes of all of that material just decaying there and not on every power plant site in the country. But it's failed to pass because there's concerns about moving that nuclear waste through every state just to get it there. And this concept of NIMBY, not in my own backyard, people just really don't like the idea of this material kind of traveling through their land, and what happens if there's a spill along the way. And so ultimately, the only solution that we have in the United States is to keep it on site indefinitely. So I think there's a lot of potential for nuclear energy, but I think that it's going to take some technological advances to really push it to the forefront to be something that our government and our country accepts as a way to generate electricity. So we're going to move on to hydroelectric. We've talked about damming of waterways as a way to generate hydroelectric or to generate energy for hydroelectric power. So let's look a little bit more about how that takes place. So the premise here is that we're harnessing the flow of water, which generates naturally generates a potential gravitational gradient. And as the water builds up behind the dam, it creates this potential energy gradient. The water will then be pushed through this channel, and as it's being pushed through, it's going to turn this turbine, similar to what we saw in the fossil fuel burning power plant or even in the nuclear power plant. This turbine will then turn, and then it will turn the generator, which generates an electrical current that then pushes that electricity out from that plant onto the power grid. The upshot is that it does not emit carbon emissions, carbon dioxide. It uses water to generate electricity. And so you might think, well, what could be the downside? Well, while there aren't greenhouse gas emissions in the way of carbon dioxide, damming up water can slow the movement of water, which can lead to decomposition, which can increase methane emissions. And so, and it really kind of depends on what part of the world we're talking about, where it could be greater or less than, depending if we're talking about tropical or temperate regions. But we do have a risk of emissions as a result of that, even though it may not seem obvious. They're also changing the way that the water flows, which can be detrimental to the people that live there, but also in the ecosystem. You have issue of fish migration. One way around that is they've created like these little channels called fish ladders to allow fish to move through and not be harmed, but that's not everywhere. It can also change many things that we've already looked at, like water temperature, chemistry of the water, the flow of water, and buildup of silt. So it is not without some consideration. And the other thing is that not every dam is hydroelectric. Only a proportion of them are. Perhaps if all of them are, maybe this would overcome the environmental challenges of just having the dam there. But there are reasons that waterways have been dammed, usually for recreation. That is not just for hydroelectric power. And we've even said that some of those dams have been removed. So there's a trade-off between using hydroelectric dams for electricity generation. And right now, there really isn't any push to put in more dams for hydroelectric power. But perhaps retooling some of the dams that are already there that are not hydroelectric could be an option. Okay. So anybody heard of geothermal energy? This concept is one that makes a lot of sense, but it really kind of depends on where you live. If you're living in an area where geothermal reserves come to the surface, then you can really make use of them. Other places, their geothermal reserves are quite deep in the Earth's magma. And so it really kind of depends on where you live. Let's just look and see how it works. The idea here is that you can take this geothermal energy and generate electricity. For the longest time, this was used to heat homes and buildings in other parts of the world, including Japan and China, but also in Iceland. In some cases, it can make the buildings so warm, you actually have to open them up in the wintertime. I had a good friend that did a sabbatical in Iceland in the wintertime, and he said that it was just so warm that they just kept their windows open in the winter because the heat was so great. So enhanced geothermal system, or EGS, generates electricity by harnessing this really hot material that is deep in the Earth's crust. They drill holes through the granite, typically it's granite, and inject water into the hole, and it turns to steam. And again, this steam then flows back up, and then they're harnessing the steam, okay? One of the cool things is the United States has widespread underground heat and could actually use this EGS system. But if you look at the price tag, it's fairly cost prohibitive at this point. So you can see, if you click on this link, you can see it's kind of like fracking, where they have an injection well and then they push the water through, and then the steam comes up through here. So rather than capturing natural gas, they're capturing steam, and they're using that to turn the turbine that's going to generate the electricity, just like what we saw and all the other examples of power plants. So this is Iceland. 25% of electricity in Iceland comes from their harnessing of geothermal. So how about in the United States? How feasible? Well, the darker shaded areas represent the geothermal potential, and you can see that in many parts of the West. This is definitely something that can be an option here. But if you look at the Midwest and even in the East, this is not as feasible. Does it mean that we have to have one solution for all of the United States? Probably not. I think the challenge moving forward with trying to replace fossil fuels is finding alternatives that make sense given the geographic region. One of the reasons why fossil fuels have been so successful is you can use it anywhere. You're not having to overcome some of these challenges like nuclear has, or having to be near water, like in the case of hydroelectric, or having to have these reserves that are accessible, like geothermal. So wind energy has gotten a lot of attention, and having grown up on the coast, this is something that we see wind turbines both on land and in the ocean. And here in the Midwest, they're starting to take hold. And, even in parts of this county, we have quite a few windmills. So how do they work? Well, actually, even before we get into that, something interesting to note is just how much what we would consider the global cumulative capacity measured in GW over time has changed. So there has been a decrease in cost, and that typically happens with new technology. As you increase in production, and the decrease in cost precipitates. So At first, it's expensive to use the new technology, and as more people adopt it, it becomes less and less expensive. And then it also leads to an increase in adoption of that technology, and that's what we're seeing here. So the wind turbines that we see are these kind. But it sort of starts with this idea that windmills in, say, Holland started with ones you might recognize here. And then there are these kind of funky ones. These are called egg beater shaped. And these are meant to take up space or take up less space, whereas these blades really need a lot of area to be able to rotate. Okay, so this would be a familiar landscape to us. And this is what I would see on the coast of Massachusetts. And there was a lot of concern that putting in wind turbines out in the water would decrease recreational value, that people that were coming there to enjoy the environment would be deterred by these wind turbines. Ultimately, wind turbines won out because another consideration is the fact that just as we don't really want to see these, we don't exactly really want to see smokestacks from fossil fuel burning plants on land either. So this has definitely become part of the landscape. So wind energy is sort of a complicated issue in that if you try and look at where the United States we were able to harness, things have changed from 2007 to 2015. The ability for energy to be generated from wind has increased. And so that's good news, particularly in the West and in the Northeast. Southeast really is not, has not adopted this to the same degree, in part because of the jet stream and the way that the wind flows. Typically is harder to harness that wind for electricity generation. So the premise of how a wind turbine works is that the wind turbine, let me go back a slide or two. We didn't talk about that yet. Sorry about that. So the idea here is that inside this head are these three blades that rotate in the air. And one of the cool things about this is that they're high up enough off the ground that they're able to capture wind that maybe we wouldn't even feel standing on the ground, but is up there in this current in the atmosphere. So these are turning. As they turn, this rotational turn actually turns a turbine. When it turns the turbine, it actually rotates the generator, which generates an electrical current that moves down from the blades down the tower and out onto the power grid. There are a couple of challenges with this system. The ability to put in these wind turbines and have them generate electricity is usually not the issue. Companies can put them in and maintain them for a municipality, and that works really well. One of the issues is that there's no way to store this electricity when it's being generated. It has to go right onto the power grid. If it's not needed at the moment, there's no way to store wind energy. So there are times when even on a windy day, the wind turbines won't be turning because their energy is being harnessed from other sources, and so they're not going to make use of the wind. The other issue is efficiency. The rate at which electricity is generated in a wind turbine is lower than it would be in other forms, definitely compared to nuclear. So depending on what other sources of electricity that you're drawing from, maybe it's fossil fuel burning power plants, and you're supplementing with wind, if there's enough energy being generated for electricity from fossil fuel burning power plants, they're not going to shut that down and let wind take over, because wind's efficiency is not nearly as high as fossil fuels. So that's kind of where we are at the moment. Other things to consider besides it being visually impactful, and the risk of certain issues with the wind turbine, they're more at risk for catching on fire due to their lubrication fluids. There's also a risk to animals that fly, like birds and bats. There is definitely an increased risk for them as they'll collide with windmills. And it can have an impact on the natural habitat. So something that I saw that was kind of interesting where I lived is that they put in these wind turbines in an industrial park. So the park was already there and it had many companies and office buildings. And so I guess you could maybe say that the environmental concerns were less because that area was already highly disturbed. Whereas if you were to say put it on farmland that was undisturbed, maybe that was more of a consideration. Okay, so on when we were together on Friday, we were talking with Dr. Summers, and he brought up solar energy. And I had already mentioned that there have been some concerns with the use of solar panels for generating electricity, but let's get into that. So the premise of use of solar energy is pretty simple. Basically, take the solar energy and convert it to electricity. Solar is constant, ever present, and the amount of energy that's hitting the earth, even if we could harness a fraction of that, we would be able to really satisfy all of our needs. In fact, if we calculated it, the sun would give us 10,000 times the energy that we currently use. So why aren't we doing that? The biggest issue is the collecting and conversion of that energy to electricity is a challenge right now, as well as the ability to store electricity generated from solar panels. We're just not there yet, similar to wind. There's two ways by which we can take solar energy and use it to produce electrical energy. And one of them is the use of photovoltaic cells or PV cells. The premise there is that there's a wafer of material that has silicon and a couple other metals in it where a wire is attached to the top and one at the bottom. Solar energy will hit that wafer and that gives an electrical current. And you're able to essentially harness the electrons through that system to generate an electrical current. These PV cells are highly sophisticated, and the way that they're fabricated does use precious metals. And so that is also something that we have to consider in this example. And they really kind of work as semiconductors, and the electricity is generated as the energy knocks the electrons loose and allows them to flow freely. The issue, though, is the rate of efficiency. Sometimes you have not enough energy that is harnessed from these photons, and so or too much energy, and so some of that energy is lost in the process. So this is something that is an issue and something that we're working on, which is increasing the efficiency. It's got a similar efficiency rate, similar to wind energy. And so if you take wind or solar and compare them to, say, fossil fuels, they're not nearly as efficient at generating electricity. And so that's another reason why they're not surging to the top. Of course, with new technology comes improvement in efficiency, but it takes time and it costs money, and we're just not there yet. Okay, so a PV cell looks like this. This is the premise of what would go on a roof. In the Northeast, solar panels are really gaining in popularity. One of the things that companies will do is they will come out and solar companies will come out and instead of trying to have lots of land by which they put these solar panels on to try and generate electricity, they'll use rooftops. And so the way that they'll get a household to agree to this is that they will offer to replace their roof and then put on the solar panels on top of that. And then once the solar panels have generated enough electricity to pay off the roof, then the homeowner can start recouping some of the cost of those of what the energy is being generated from. And so basically they can make money off of the solar panels that they are using to generate electricity. So that's pretty exciting. Another way that we can see the generation of solar electricity is using these solar collector fields. Basically, they're taking these panels and laying them out in fields, and they're running water through them. And as the water heats up, it's going to generate steam, just as we've seen with the other types of fossil fuel burning power plants. And ultimately, it's going to run through the system, turn the turbine to generate electrical current. We don't see that as much here in the Midwest, but out in the West, this has become more popular. Now, one of the issues with solar energy too, which might be pretty obvious, is the amount of solar energy that reaches the Earth year round varies in the United States. So in the West here, you can see that the solar energy potential is a lot higher, right? Because the amount of sunlight in that region is stronger than, say, in the Northeast. Southeast is a little bit higher, but maybe not as high as you might think it should be, because it is the Southeast. But really, where you can generate the most solar energy would probably be out in the West, and that's a challenge. So environmental concerns include when you're manufacturing these photovoltaic cells, there are solvents and alcohols that are needed, as well as some precious metals. And depending on how you do it, it can take up a large footprint. And if you're talking about using those panels to generate electricity by heating up water to steam, this does take a large surface area. Okay. Another one that we've sort of alluded to when we're talking about biogas, when we were talking about what was happening at the biodigester at the Marin Utilities, and when we're visiting their water treatment plant. Biogas is one of them, or landfill gas. But wood or rubbish or alcohol fuels or biomass from crops, these are all ways to generate electricity, basically from recycling stuff that we're already using. It's kind of an intermediate between, well, it's an intermediate of fossil fuels. If you let this material break down, ultimately it would become fossil fuels. But because of that, the energy density isn't as high as, say, fossil fuels. The upshot is that you're recycling what would be waste and using it to generate electricity. One of the downsides, though, is if you're using land to produce wood that would be used for fuel, or crops that would be used for biofuel, you do risk conversion of land for fuel. We already kind of mentioned how even if you add ethanol into gasoline as an alternative to other materials that went into gasoline prior to that, it leads to a potential risk of erosion. So there are definitely some factors involved that make biomass both have great potential, but also there are some drawbacks. So wood has been something that many countries have used for a long, long time to generate heat, but not so much electricity. But because of that, there is a risk that we may not have enough wood to be able to meet all of our needs today for using of this resource. So wood has not been the primary use for biomass. However, biogas, just like we saw at the municipality here in Marion, which is a result of anaerobic digestion of sewage sludge or other things added to that sludge, maybe it's food waste or manure, can be digested. And this is huge in other countries and is starting to take off here in the United States. So I think one of the things that I want us to think about in this unit is just the potential that all of these energy sources have for our meeting of our needs for generation of electricity. So is it possible that any one of them could take over as our main source of electricity generation? Maybe. It's going to probably take some time, some resources, some technology to be able to see this come to pass. But I think all of them have potential. So we're going to spend some time when we come back together on Friday thinking about this and really kind of comparing and contrasting them. All right. I hope you guys have a really good week, and I'll see you on Friday.